I am Matt Scholz with the Sustainable Phosphorus Alliance, and I'm joined today by Professor Brooke from Marquette University. Thanks for joining us today, Brooke.
Absolutely.
And we're going to talk a little bit today about your environmental science and technology paper, Total Value of Phosphorus Recovery, one of my favorite papers coming out of 2016. And maybe you could tell us a little bit first about why you did this work.
Sure. So this really stemmed from our group that brings together environmental engineers and bioproducts and biosystems and sustainability scientists and engineers.
And this is the NSF's Phosphorus Sustainability Research Network.
Exactly. So from different perspectives, people coming together and saying, hey, phosphorus is a big deal. We know that we have the agricultural side where we're going to have a need for it. We might be running out. But on the other hand, we also know directly that the water quality impacts are a big deal. And so kind of the basis for this paper, bringing together all of our different researchers that you see here, is just closing the loop on that cycle and saying, all right, we need to do this. And we know that there's this double benefit of environmental water, and then there's also the security of having the phosphorus as a source, as a supply. But we know this is a need, but it's not happening. And so we know that there's some big barriers in place. And so this was an attempt to try to explore those and say, if the value of the phosphorus product itself isn't going to be sufficient to be a main driver of recovery, how else can we look at this and think about the total value of this recovery process? And so we came at it from that perspective and thought about the phosphorus itself as a product, but also, can you co-recover other products? Are there other services that this is going to do that are maybe difficult to monetize directly, but if we account for the whole thing, then phosphorus recovery becomes favorable. So that was our approach.
Yeah. So what are you thinking about in terms of co-products and services?
So absolutely. So when we think about our products and our processes and our services, there's a number of different things that can happen. And all of these we see as driven by kind of these major global changes. And of course, thinking back to the link between energy and food and water and the nexus. And so even though we like to talk about things separately, you can't separate them. And so we considered products like nitrogen or water or other things out of there, and also the key services that go along with protecting environmental quality. Do we have a social equity aspect? And so kind of pocketing all of those and thinking about all of them as a total system. So like I mentioned, some of the products were the phosphorus itself, and that could come as like a mixed organics, like a sludge or a organic compost. But you can also have recovered struvite or calcium hydroxyapatite.
Sure.
At the same time then, though, we have energy and nitrogen and metals and minerals in the water itself. And those things tend to hold higher value in general than the phosphorus product.
Okay.
So if we can co-recover in a system, then we're going to look at an advancement in the technology and the actual approach to recovery.
Okay, great. Any other figures you want to go through from the paper?
So this one that we're looking at right here, this is actually an example of wastewater reuse. And so we're trying to explore the drivers that would push phosphorus recovery forward in the future. And so we use wastewater as an example because there's a lot of good data on that. And so in this figure, we're looking at water reuse on the y-axis versus water risk. And risk takes into account things like quantity and quality, and also regulations in specific countries. Okay. And so we gathered some of this data and then used correlations, and we plotted this against a number of things. Water risk was one, but also GDP to look at economics, and education to look at progressive. And we found that the only positive correlation here was actually water risk. So the bottom line is that regardless of what's going on in a country or people's perceptions of reuse, it's going to come a time when there's a need and there's no way to escape it. And so if we think about how that relates to phosphorus, if we're going to hypothesize in the future, then we could probably consider that the same thing is going to happen, where we're looking at when the need arises, when there's no other phosphorus source, we're going to have to do it. So we're in a better place if we have systems in place to address this beforehand. The other part of this then is the services, and so you can see them laid out here. So we think about protecting water quality, and that's the only one that's regulated really right now. But also just improving operation and facilities. So if you have struvite precipitation in pipes, it can be really expensive. And then improving food security and social equity, and we'd see those as playing into the UN Sustainable Development Goals.
Sure.
So those would be big parts of it. When we think about all of these things, then they led into what can we do to progress this, and what are the needs to make this total value a possibility when we look at the whole scope. And so some of the things we considered were the technology. We know that this is one of those types of problems that technology is necessary, but it's not sufficient in and of itself. So in addition to that, we're going to have to think about the economics. We have the business model, coming at things from a systems level. So can we analyze from a life cycle assessment point of view? Thinking about other policies that might drive this. So whether that's renewable energy, other ways where, again, if we co-recover a product, it makes that phosphorus recovery easier to do. And then also just making sure that the public is aware of what's going on in that situation.
Okay, and so there are some different technologies that exist for extracting these nutrients. Do you want to talk a little bit about what your paper went into with that?
Yeah, so that's perfect because there are a number of technologies and people have been researching a lot of them, and some of them you can see on the screen here. And they target different aspects, so whether it's the water itself or the sewage sludge, or if we're thinking about incinerated sewage sludge ash. So there's a lot out there, but one of the things that we think is going to be really helpful in the future is to think about these technologies that exist, but also are there other non-incremental ways that we can approach our desirable attributes. So those might be things like thinking about the cost of the inputs, energy and chemicals, the product itself. So if we can get a more pure phosphorus product, that'll help with the marketability of it. And anything that comes into design, we want to start with the main goal being this recovery of the total value. So not just focusing on the phosphorus itself. So I think the next step is to actually follow up on some of the more quantitative analysis of it. And that could include the designs themselves of technologies and improving them, but also thinking about applying, say, techno-economic analysis. And we know that there's some kind of budding tools to think about social metrics. So we know that we have the cost that we can look at. We have the environment. But social LCAs, for example, I think would be a big improvement to actually looking at how we can put a value on these, so that now that we know what to include in that assessment. So I think that would be a great next step. And one of the things also that we thought about was, for example, here we're looking at where can we target this? So where is the best place to put it? And kind of Geographically, so country-wise, and we kind of base this on, first of all, the need, like we talked about with water, but also in that sense, does infrastructure exist? So if you're going to recover it from a waste product, if you're already doing water reuse, for example, then you're going to have an easier time.
Sure.
So one of the ways that we thought looking forward is to kind of think about it in this graphic. And if you look at the right-hand side of it, these are the countries that are critical to get phosphorus in. They don't have it. So it's probably going to be an easier bet to start off there. But on the other hand, if we look at the y-axis, so on the top of that, we're looking at countries that have infrastructure in place. So these might be places where we could actually have fertigation, for example, if we have the nutrients in the wastewater. Or if we're looking in that bottom quadrant, the Q4 on there, that's probably our biggest bang for our buck. So they have the need for it. They don't have the infrastructure in place. So if something is put in that's designed to get this total value, it's probably our best shot at it.
Because they can recover the value in so many different ways.
Exactly. Take full advantage of it, going with that design purpose in mind.
Right. Yeah. Well, great. That's a great summary. You have one more graph here. Let's take a look at this.
So another thing that we can look forward at doing goes back to our P technologies, and this is just an example of some of our analysis that showed that we still probably get the most value from the liquid phase. So our recovery technologies are targeted there. But if we think about then, this graph is only looking at energy and costs. If we actually tie in the environmental and social aspects, I think there's a good argument that we could look at technologies from many of these different matrices that are really going to truly target the total value aspect.
Okay, great. Well, thanks so much for taking the time to go through this with us.
Yeah, thank you.
Yeah.